Welcome everyone to the Microsoft Access Beginners meeting. We are delighted to have you here. My name is Juan Soto. I'm the founder of AccessUserGroups.org, as well as the chapter president for both Access Beginners and Access with SQL Server. Access with SQL Server meets on the first Tuesday of the month. Access Beginner meets on the third Tuesday of the month. If you're watching this on YouTube, thank you. Make sure you do the like button and subscribe and notification bell. It all helps. We all volunteer for this, and so everything you can do for us, we'll appreciate it. But we would love to have you in the live meeting. So if you would care to join us, that'd be great. As I said earlier, we meet on the third Tuesday of the month. You can see a calendar of events at AccessUserGroups.org/calendar. And tonight we have a very special guest, Steve Owen. He is a senior access consultant at IT Impact, the firm I manage, where we do consulting work for access. And I'm delighted to have him. Steve, good evening. How are you?
Oh, I'm doing wonderful, wonderful. A little chilly here in Chicagoland, but we're going to survive.
Well, thank you very much for joining us tonight. And today's a very special topic because we'll be talking about relationships, not the personal kind, right, Steve?
That is correct. I am not a psychologist or a psychiatrist or any of those.
Well,
Am
look,
I-
Steve, yeah, I see you put quite the presentation together. Let's go ahead and get started. Without further ado, let's get this presentation going. Thank you.
Well, good evening, everybody. As Juan mentioned, today's session is going to be about managing relationships, primarily as it relates to Microsoft Access. Even though a lot of this will apply in the world of SQL and other relational databases, at least from the theory aspect of it all. So tonight we will be going through several items. The first one is kind of a prelude, where we discuss the things that we need to know in order to build a relationship. Then we will move on to types of relationships, things like one-to-many, many-to-many, one-to-one, and so on. Then we'll look at, do we need relationships, and when should we use relationships, and when shouldn't we use relationships, or when isn't it not possible to use a relationship? I will then go through examples for managing relationships with your access tables, and I'll be using a kind of a framework or a building block for a service industry application. We will then go into benefits, drawbacks to having relationships and defined on tables. And finally, any questions and answers that you would have and I can address. Let me start out by introducing myself. I think Juan did a pretty good job there. I am a IT Impact Senior Access Developer working for Juan's firm. I have worked in Access since its original pre-release in the early 1990s. I was actually an alpha tester prior to its release. Past roles include managing consultant most of my career, everything from development to managing pre-sales, especially as they relate to Microsoft development platforms, as well as dynamic ERP tools, things like Great Plains, Navision, AX, CRM, and so on. I was a director of software and support for an environmental company, of which this is a part of their system that we're going to be looking at, some of the core infrastructure. And my latest gig prior to joining IT Impact is I was the data migration lead for a state child welfare system, basically converting 250 million records in a weekend. And we used Access as our primary data dictionary and mapping tool for that entire process. We were going from Oracle to SQL in this particular case, but Access was a fabulous tool to manage that process. Now, before we can discuss relationships, there are a few key elements to which we really must address and have to know and have a firm understanding of. And that is primary keys. Primary key is, as you sure you know, it is just a unique identifier that associates that record to a single ID. It could be a single field, or it can be multiple fields to make up the primary key. Characteristics are each value of the primary key must be unique. It cannot contain any null values. It can be single or composite. Basically, it could be one or more fields that make up the primary key. The second important element is the concept of foreign keys. So a foreign key is basically just a reference, a value in a table that references a value in another table. It must reference a primary key. So if we are down in this example here, we're looking at the entity phone numbers. You can see that its primary key is made up of entity ID and entity phone ID, and the entity ID has a foreign key relationship with the entity ID of the entity table. Basically, what this allows us to do is share data while maintaining integrity, meaning you can't input a phone without having an entity, an account, a vendor, or what have you. So these are key elements that we're going to be going back and forth on throughout this. Is what does the primary key look like? What does the foreign key look like? And then how do we build the relationships based on those structures, those predefined structures? We have three main relationship types. There are several other relationship types to which we will not be getting into this example, but I will briefly comment on them. Our primary one, the one that we use the most, generally speaking, is the one-to-many relationship. Basically, for every master record, we have many detailed records, customers to contacts, orders to line items, entities to phone numbers in this case, in our example. We have one-to-one relationships, less common. Basically, for every one record in one table, it's got exactly one record matching in another table. The use case for that, we'll describe it and when we get into more detail on a one-to-one relationship and how we set up and configure. Many-to-many. This is a little more used than the one-to-one. Basically, what that says is we have two master tables. In our case, it's going to be entity accounts and properties. And we want to have a way to associate any number of accounts to any number of properties and vice versa. So we create a junction table and we link those accordingly. And again, we'll go into much more detail as this session progresses. There are others, but that's another story, but I will mention them briefly. You can have a relationship, a self-referencing relationship, basically where you have something like a employee and the employee manager. That's a logical relationship. It's all in the same record. You got the employee and then you associate that to the manager. We have another hierarchical type of relationship where you can have a file system, for instance, where this record has a parent record and you select another entry within the same master file. It's used a lot. I use it a lot for task management systems where I have one task management table and I build a hierarchy throughout that process. So it is used. Whether or not we can actually formalize that relationship in an access, only maybe with the use of views. I don't think there's any real natural way of of doing it, but it is a logical relationship within the structured database.
Now, Steve, does anybody, does every table need to have a relationship with another table, or can they be standalone as well?
Oh, you do not need to have a relationship at any time on any table. And I kind of go through that a little further down, where I discuss the fact of when should we and when shouldn't we have a relationship within a table. But absolutely, there's no need to build a relationship. And my guess is people don't generally do it, and from my experience as well. Hopefully, this session will tell them why they should do it and provide them the necessary tools to determine whether or not to build a relationship on a particular table or group of tables. So like I said, our primary one-to-one relationship, one-to-many relationship, this is one you see all over the place. This would be anytime when you have a single record, a parent, a master record, and it can have many children records. In our case, in our example, we're going to go through, I actually have an account table, which I actually call entity, and it has many phone numbers that can be associated with that account. Pop up access real quick here. So this table here can actually have, oops, wrong. Any one record in this table can have many records sitting in. I apologize here. Let me minimize this a little better. Actually, I think I have it directly this way. So I actually have it because we defined a relationship, it built it into my data grid for us. So I can come in here at any time and I can put in any number of phone numbers designated as primary. I can have an office number. And as we go through that, it basically what it's doing is it's automatically applying the entity ID for us because it is tied directly to this data grid as based on the relationship to which we provide it. So this is the most common. Now, another view of that, let me see here real quick. Just bring up a form instead. Another one-to-one relationship would be anytime you have a lookup table. So if I have, in this case here, I have a status lookup table, and that table contains 4 statuses: active, inactive, draft, and deceased. Basically what that is it's a foreign key relationship to that lookup, and that is changing perspective, a many-to-one relationship in that for every value that we have in the lookup table, we can have many uses for that value in the entity table. Okay, what are the key features when building out your logical table as well as defining your relationship? One is that we have to have a primary and foreign key. The parent table has to have a unique identifier. So in this case, the entity, it has a unique identifier called entity ID. The child table must have a foreign key that references the primary key of the parent table. Now, in my case, I have if we look at the phones table, you will see I have both, and I left it without a key in here just so that you can see. We could have designed this table with a primary, with the primary key being entity, the consolidated key with entity ID and the entity phone ID. But in this case here, or you could just have because it's an auto number, the phone ID is the primary key. But this is what's critical. In order to have that foreign key relationship to the parent, to the entity, we have to have a field to which we're going to associate it with. And that field has to match by type. We can't have differing types. Otherwise, it won't allow us to create that particular relationship. So that's the key takeaway here. You have to have your parent key. Your parent has to have a primary key, and your mini side, the child side, has to have a foreign key that references that primary key. What's the purpose of it? Organization-wise, it's just how it maintains a couple of things. It helps you visually see, because you can look at the relationship diagram and see how these things connect and interconnect. But it also helps maintain data integrity, in that you can't have a phone number without an entity ID field that's in that particular table. It's visually referenced. When we look at the entity diagram, you will see that the entity side is the one side. The entity side is the one side, and the phone side is the mini. So the infinity symbol represents any number. Any questions?
So basically, you use this type of relationship a lot, right? Because the whole point of a database is to have, for example, a customer, and that customer may have multiple orders.
Absolutely.
You would have a customer table, right, with a customer ID, and then you would have an order table with also a customer ID, and you don't have to retype the customer name and phone number over and over again in the order table.
Correct. It normalizes the tables. That's another word here to which it's probably fairly new to many beginners, but it removes redundant data out of the orders table. So we keep the customer's data where it belongs in the customer's table. We only provide the order level detail in the orders level. And then the orders has line items. So now we have a one to many relationship. But if we just look at the master data, we're going to have customer to orders, but then order stands on its own, and then it's got a relationship from customer to line items. The key process here is line items can't stand on their own. There's no standing on their own, and that's going to come into play a little later when we talk about enforcing constraints or enforcing auto updates and enforcing deletes. If we delete an order and we have a relationship, when do we delete and have it cascade through? And it really, we'll go through the very specific details on when that should be toggled on and off.
All right, sounds good.
The next relationship is one-to-one. You see this less often. You'll see it in some bigger applications, heavily secured applications. Probably a lot of the use is, and basically what it is for every one record in one table, there's only one matching record in another table. A lot of times what you'll see is it's a way to segment the fields. If you have a really big table and there's a lot of fields associated with that table, you may want to group those tables separately. There is certainly some optimization from an access standpoint and from a SQL standpoint on not having this one huge table, especially if you're not going to be looking at that data all the time, or there's specific business and use cases to which you want to focus on certain segments of the data. The other
One of the biggest issues people start when they start with Access, because usually they come from Excel, right? And they have this huge spreadsheet with dozens and dozens of columns. And so Excel is not a database, right? It was never designed to be a database where you have to split that data up in multiple tables in Access, and you use that one-to-one because you don't want a table to be too many columns, right? What is the issue with having a table with too many columns?
Well, there's other issues as well. I'm working on a client right now where they are writing back to a master table information regarding RFID tracking. And this table is a very monster of a table. It's huge. And they're constantly writing data back and forth to that master table. And if somebody is sitting on there trying to edit a schedule, they're going to get contingency issues left and right every time that they post data back into that master record. So what I'm doing is I actually broke it out into into another table that I call schedule RFID, and it's a one-to-one relationship. But I can pound that table without worrying about any contingency issues or locking issues for people working through the day-to-day operations of managing their this particular production line schedule. So there's valid reasons, and it probably should be used more than it really is. Then there's indexing and all the behind the scene things that also occurs that add benefit to utilizing such a thing. But this is more from a practical standpoint on how to use a one-to-one.
All right.
Again, primary key, foreign key. The primary key and the foreign key in this case can be the same, and most times it is going to be the same. So in our reference, we have entity ID. So my entity has entity ID. And then I created a table called restricted data, and its primary key is entity ID. So it's going to force a one-to-one relationship between those two tables as we go through it, and as we start adding records and organizing it. How this looks is in the visual representation. When you build that link, we can see that we have one-to-one relationship. So it explains to you by visually looking at it that, hey, entity and entity restricted have a one-to-one relationship. So you can visually tell how these things are joined. The next one is the many-to-many relationship. This is another one I don't think gets utilized enough. Basically, what this means is we have two master tables, accounts, and in this case, properties. They stand on their own. They contain all their own information. They have their own data entry forms, and they mean certain stuff for different people. But we need to be able to associate an account to a property and collect additional information as it applies to that one property. So when we say we have a many-to-many relationship, basically what that means is for every account, we can have many properties. And from any property, we can have many associated accounts. Now, you can't really define this by itself without having some sort of junction table, some way that marries these two together. And usually these junction tables don't just contain the entity ID and property ID. It contains other attributes that define that relationship. So for instance, in the case of property, I may want to know when I link an account to a property, I want to know when was the date of ownership? When was the date we did some work on it? So if something ever happens to that account, the property still stands on its own. If ownership ever changes, the property still stands on its own and all of its history. In the property case, we collect all kinds of detailed information from a phase one or any type of point in time documentation. We always want it to follow that property. It could be, my father owns a plumbing and heating contractor business. So I built him several applications over the years. And, we have to track the household where we put in a water heater or where a furnace was put in, because we need to manage the warranty work and the equipment that they have at that property. We don't care who the owner was. We may have cared while we were doing the engagement and at the ticket level, but we have to have this separation. But I do want to know the history of the ownership of that particular property over time. Basically, key features here is we need a junction table, a way to combine one entity ID or an entity ID with a property ID. And again, we can have that same entity can have many properties, and that same property can have many entities. So that's how they get the one-to-many. Now, unfortunately, in this case here, they say you must have a composite key. I disagree with that fact. You really don't need a composite key. You do need a foreign key relationship with that. So your property junction table can have its own standalone auto-generated ID. It doesn't need to have the primary key being equal to entity and property. Data flexibility. This relationship allows for complex associations between entities, providing flexibility in data modeling. Another area to which I've used this a lot for is when building a CRM system or a contact management system. Many times you want to be able to, for a company in your entity table, you want to associate all the employees that work for that company. But it's not a one-to-one relationship, because I also want to associate for that particular person all of their family information. So I build out these junction tables to where I can combine contacts and accounts and allow them to have all these advanced relationships, like, yeah, they're the CEO. This really comes into effect with associations, where you've got the same person who is an employee of one of your customers, but he's also a member of an association to which you do work with, and you want to make sure that you combine and you have a full representation and relationship of, for instance, Steve Owen. Steve Owen works for Juan at IT Impact, but Juan. But he also has a wife, Mary Owen, who's a part of our contact list, and so on. So we can build all of these complex relationships by utilizing a junction table. Visual representation, there really isn't one. That's kind of an interesting point here, in that there's really no such thing as a visual representation for a many-to-many, in that the only way you can do it is, I'm gonna add my junction table here. And that junction table is going to also include the property information. So this entire relationship, when I link entity to here, I'm just going to say create, and I link property to here, and I say create, I'm going to say enforce referential integrity. Enforce referential integrity. So at the end of the day, what we end up with is a one-to-many and a one-to-many. There is no such thing as infinite and infinite. Any questions on the many-to-manys? Nope, good to go.
I mean, for someone who's starting out Access, I don't recommend that you start with many-to-manys, right? I recommend you do one-to-many or one-to-one. And
Correct.
then when you can't fit into those two relationships, like Steve says, you have an apartment and you need to associate the apartment with multiple owners, well, then maybe that's a good example. And I don't use it that often. I mean, how many times have you used a many-to-many relationship?
Oh, probably any big contact management system, or any big service industry system where we have to track either households, properties, and so on.
Okay, all right, fair enough.
A flagging database, if you got flags and so on and so forth, if you want to apply flags across different flags and so on, across many different objects, there's a lot of back and forth on there. Okay, now the many-to-one relationship is nothing more than the one-to-many. It's just change of perspective. If we're looking at if we're looking at this is a status table. This shows a one-to-many relationship, because for every one status, there are many entities that utilize that status. But if our perspective is from the entity side, you're going to describe that relationship as a many-to-one to your reference table. It's one-to-many, but these can stand on their own types of scenarios, right? So I threw that out there just for the fact that you're going to hear it. If you're ever describing your relationships in a textual format, that's what you're going to end up with. Okay, so now the question is why should we define these relationships? What's important about them? I kind of asked the question, is logically defining the relationships and normalizing your data makes perfect sense? Absolutely. Do I have to have a defined relationship based on my table structure if I've accurately defined my table structure? Well, I'm still going to say yes, you do. The key component of here is still knowing how to actually build your tables out so that you're logically thinking of what the relationships are, but to physically define that relationship, whether it's within Access or whether it's a constraint within Microsoft SQL Server or Oracle, there's a lot of benefits to that. Number one is you can enforce referential integrity. And basically what that means is you can't have one without the other. Now, if you got a one-to-many and you're sitting and you're trying to input data into the phones table and you don't pick an entity that's in the table, it's going to blow up on. So it really, it keeps your data clean. And basically, so you can't be adding child tables without corresponding parents. It provides some automated cascading benefits. So you can, if you delete a parent record, you can have your property cascade delete and remove all reference data elements that fall underneath it, all of the child tables. That one you got to be very careful on, and we're going to go through when and why not to use it and a little bit later when I get into the actual going through this application. Updating a primary key automatically updates the foreign keys. So basically, if you change the entity ID, it will automatically change all the entity IDs in everyone that is linked to that. Now, the practical side of this, do I ever use that? I don't, because I don't have anything that the user would ever touch that would change a primary key. So mine are always auto-generated in some form or fashion. And a user never has any ability to go in and change a key once it has been generated. Are there use cases for it? I'm sure there are. I'm sure there are. And I'm sure a lot of people do a lot of that. Me particularly, not so much. It can help in some regards if you're doing data migrations and interfaces and integrations, and you're taking your data and you're stuffing it into interface tables, and you go and you look and say, hey, I can't load this customer because customer ID 1 is already utilized. So now you got to go change all of those interface tables to be customer ID 2. Having that auto update saves you a lot of time. Then you can load the interface tables into your primary data stores. So there are use cases where it can make your life a lot easier. Prevents orphan records and to ensure data's consistency. Basically, an orphan record is you got a child with no parent. And because we can't load a child without a parent when we have integrity on, it takes care of that for you. Performance and ease of developing. Access uses relationships when creating queries. That's if you set the join options on the relationship model, and we'll go through that. And it does save time and reduces errors. It manages the joins for you when you drop on into a query window entity and you drop on phones. It's automatically going to create those elements for you. So as you can see here, I've got entity, I got phones. So now if I come in here and I create a query and I select these guys, it automatically builds that piece of information for you. Normally, if you don't have the relationship, you drop the tables, this is what you see. And then you got to come in here and you got to do all of this fun stuff. Tell it how you want it. You want to see it, everything from the entity side and those that match on the other side. That saves you a lot of time. If you're bringing over a lot of information, you got a lot of lookups. I mean, I've got some tables that could have 20 different lookup value tables. So it will save you development time. The last one is it increased performance gained via Microsoft Access optimization. Now, this is true. And how does it do that? It helps improve the query plan that Access uses. This is also very true, and more so true in the world of SQL Server. But in this case here, Access is behind the scenes building out these execution plans to determine the best way to produce that data. Because my question to myself was, will a predefined relationship be faster than a well-formed data structure and a well-formed query? Yes, it actually is faster with the predefined query and how it does its calculations and its utilization of hidden indexes. Now, I can't really prove this is true. I'm supposing that maybe Juan knows what are the statistics behind this. So basically, in theory, this improved query plan, it's done on the save of a particular query, and then when it runs, it utilizes that plan and these hidden indexes, to which should perform better than if you do not have a predefined relationship. I do plan on experimenting with that a lot more, but as I put down here is the details and specifics of how and by how much is out of scope of this presentation. So, you have any comments on?
No, I wouldn't worry about it. I would move on because it's a high-end topic. And basically, if these are newbie databases, the performance is going to be great.
That's going to be great. Exactly right. I agree. Some other things it does allow you to do, if you use the form wizards, it'll auto-generate the drop downs and the list boxes and all of that based on your reference tables that you have set up in your relationship model. Based on what we saw, there's improved performance, why we should create these relationships. We saw improved performance, ease of use helper functions, data integrity. Now, there's times when we don't want to use relationships. Temporary or imported data. These may be non-structured. You know, you're not going to go through and create the necessary structure if you're just loading data and then taking it and immediately transferring it into the live table or data elements. You're not going to build those relationships out. Performance issues on large databases. Imagine if you had update all or types of scenarios. There's natural performance issues automatically on the fact that it's adhering to and managing the integrity of the data. But if you allow for cascading deletes and cascading updates, and it's constantly got to check with that, the bigger your database, the slower it's going to be based on that relational model. Again, this is extremely large databases. Not sure how much it really applies in the world of Microsoft Access, much more so particularly in a SQL Server environment. Flexibility of requirements. There's just times when you can. You have complex relationships and you don't need the foreign key, primary key mirroring. So you have to go through and not apply them, and you have to programmatically manage your data and keep your data clean. When you're not in control of the data structure, meaning some people you're working with legacy systems or you're working with external systems and their data types are not compatible. They may work. You could have a GUID and you could have a large text or even a short text, and you can connect them and you can manage them and you can do all of that stuff programmatically, and even within your forms engine. What you can't do, though, is create a relationship. It's expecting a certain type of value or a certain type associated with each field, and they must match identically. Otherwise, Access will not allow you to create that data, that link. Orphan records. If your legacy data has orphan records, then you can't put on a relationship and have integrity because you've already violated the integrity upon the creation of it. Now, should this be a cause for that? No, I think you should clean up your orphan records. This definitely would prevent you from creating a relationship. Okay, so now I'm going to go through real quick the tables and the data model to which we've seen some of. We've seen how I've implemented the entities and phones, but we're going to get into a little more detail so I can show you how the one-to-ones work and when cascading deletes work and so on and so forth. This is all based off of a ESA system, an environmental site system, where we basically went out, did phase ones, collected all of the government documents and everything for it so that people can buy the property and feel good that it's passed this particular inspection level. It's a relatively simple system, but what's important here is we have accounts, the people who are paying for us to do this evaluation, but then we also have the property where we have to store those records for a number of years, regardless of whether or not the account goes away or not. So this was a good example for me to illustrate the many-to-many scenario. We're just going to be looking at a few tables, though. This is the primary master tables. The ones in green, we have property, we have account, and we have tickets. I'm not really going to go over tickets, but I do have an interesting thought process on tickets and whether or not that could be, in theory, considered a junction table. But there's reasons why it's not, though it has property and it has account and it joins them together. There's other requirements to be a junction table. The accounts table, it has two subtables, and basically that's the account restricted data and the phone. So in this case here, this is a one-to-one relationship, and for accounts to phones, for every account, we can have many phone numbers. It also has two lookup tables. It's got one standard lookup table. It uses account status, and it's got kind of a hybrid. I wanted to use this to show cascading updates and that, but it's got a flags table. This contains all the allowable flags to which we can associate to an account. Property table. We would have many more data elements tied to this, but I just wanted to really focus on one master with the subs and lookups, and then how they relate to each other from at the master level. Ticket, same thing. We would have many subtables for this, all kinds of lookups, again subtables, and so on. And I do mention down here, could this be a junction table, many to many with property and count? And again, we will explore that later on why that doesn't meet those criteria elements. And finally, we have the account property association. This represents the many to many setting. So for every property, we can have many accounts, and for every account, we can have many properties, and it's all administered through this one account to property association table, which has primary key of entity ID and property ID. Property ID has a lookup to the role. So for the combination of property and account, I want to know what the role of that particular relationship is. And in this case, it would be things like ownership, bank, whatever. So the remainder will be utilizing this whole table structure, our data model, and let's get going. So first thing we need to know how to do is how to build a relationship, and how do we get into the relationship pane within Access. So from Access, from the database tools window, you can go right into the relationship builder. In this case here, I am going to get rid of some of these relationships. Just so that we can start from fresh. Okay. Okay, so based on our picture that we had, we're now going to go in and we're going to add our tables and start picking the fields to which we want to associate with them. So normally what you would do, delete this as well. From either our add tables window or from the database object window, you just come in, you drop them. We're going to focus on the entity and phone numbers. Once we have our tables in our relationship pane, we now can associate them with one another. What I'm doing here is I'm highlighting the entity ID, I'm dragging it down, and you just throw it in there and it will find where you dropped it. As you can see here, I did entity ID and I had my cursor over entity type, and it made that association. You can come in here and change it that way. Now we've got several options on here. So basically what this is telling us is for our tables, we've got TBL or ENT entity and phones, our fields to which we're going to link. Both of them are entity ID. It automatically determines the type of relationship based off the key structure of both tables. And at that point, we can say create. Now, as you can see, all we did is create a relationship. We're not enforcing any data integrity. It doesn't care whether it's a one-to-many or not, because I can add any number of phones into the table, and I do not have to have a master record. So because we didn't assign the data integrity aspect of it, it allows me to, it doesn't provide us any benefit as far as the integrity rules are concerned. So from here, I'm just going to go in. I'm going to say enforce integrity. Say OK. Now we see that we have a one-to-many relationship. I come over to the phone number. And now I get a blank error message. Does that look blank to you guys?
Yeah, it does look blank to me.
Yeah, I have never seen that happen.
There it
you
is. So it says you cannot add or change a record because of a related record required in the entity table. So it's doing its job. It's not letting us create that record in there. Now, other options here: cascading updates, cascading deletes. Cascading updates, again, really, in my world, doesn't have much of an effect because I don't ever change. I don't allow people to change the key values. But if you do, what that would allow us to do is, if I had this record here, you can see I've got two values here. If I went and changed it to 3 or 2000, it would auto update this number to match the primary key that it was originally. What I find more interesting is the cascading deletes. So now, because we have cascading deletes, if I come in here and I delete this record, into here, one-to-many relationship, turn that off. So close out our tables. Save it.
It's a different table.
You are 100% correct. Let me put that out there. Resave it. Now we're going to go into the entity table, delete it. We'll go into phones, and as you can see, the 2 value was deleted. I'm going to keep these two open and side by side here so that we can see for sure. I go and I delete 3. You can see it auto deletes those values. Now that can be good. It's good when you have self-contained data, meaning I can never have a phone number that can reside without having an entity. That would be the one area to which I would say that makes perfect sense. Now, I did want to show you how the other update works, where we can do a update and have it auto update. In this case, we wouldn't want to auto delete, and I'll tell you why. Look at this down there. Okay, so what I'm going to do here is I'm going to associate the flag name to the flag. It is a one-to-many relationship. I'm going to cascade the update. So basically, for every 1 entry in the flags, it will update every occurrence of where that flag is utilized. So I'm going to come down here and I'm going to create a flag called delete. I'm going to copy that. I'm going to go into entities and I'm going to associate that entity in there. Now, if I come out and change that flag to oh no, it automatically does the update. So In that case, if you have a reference table, a lookup table where you're not really tracking an ID and you just want it to be text as your primary key, that would be where that update would work great. Now,
Nice.
where we're going to have problems, let's say because this is a reference table, we decided to say, you know what, I'm going to have cascading delete go on. Now, I really don't think in this world, I got to close my screens down again. I really don't think we want this to be in control, this table to be in control of what gets deleted in our master record. But if you do that, bring that down, I close this down, and I bring this up and we show, and I come out here and I say delete. Actually, it won't delete it because of that fact. And that's great. So in this case here, I'm guessing because it's not a primary key, it's tying to a foreign key that's not a part of the key structure, it will not delete the underlying record. And that actually works as I would want it to work. Okay. Now, we would basically, there are other ways to which we can go through and add a relationship. You don't have to do drag and drop. I know some people don't necessarily like that. You can actually come in here. You can double click on that. You can pick the tables that you want. So I want the table entity. Actually, oh, I'm sorry. We're going to go into create new. So now we pick the tables. I go into entity. I'm going to go down to status. So the left side of this thing is the entity, the right side is the table name. I'm going to select the status ID. I'm going to say OK. And basically, it did the same thing as it did when we drug the fields over. So you can drag and drop, or you can come in here and create new. I generally don't do create new. Any questions so far?
No, I think
So
it illustrates the power of relationships because, like as you said earlier, you don't have to have relationships, but when you have them, it makes your life so much easier in terms of data integrity when you sold the example there.
well, it does, and let me show you a little bit again. So just the relationship itself. So if I come in here and I delete, I just create a relationship here to status ID. And I say enforce referential integrity. And I create. Then I come into a query. And I select entity. And I select status. Having this piece of it is wonderful. Because like I said, most tables have many, many status tables, many, many subtables. So setting it up once and then having it replicate itself over time is great. Okay, so I basically do everything we gone through here is in this document. So this defines all the little pieces that we went through. My next slide actually find it here. When to implement cascading updates and deletes. Yes, it's very powerful. With power, though, comes some concern. So when to use cascading updates? Use when the primary key in the parent table is not an auto number field and may need to be changed. That's primary use case right there. Appropriate to maintaining data integrity and closely related. Yeah, so clearly, if you don't have that set and you change the one side of it, you've now broken the integrity rules. And we did see that in when we tried to delete that one record, and we had a old relationship out there, and it said, hey, you can't do this while you still have this record out there. So that does work and work well. Useful for temporary transactional data. Again, it's kind of what we were talking about when I would use this for integrations, migrations. If I'm talking to a website and the website is building orders and I need to get that order into my system, well, it's going to have a different order ID from the website. So I need to play games with it to get it into my system to generate an order to which we're going to be using from that point forward to track all the way through the full workflow. So web order comes into our ERP system. Our ERP system then bills the customer, ships fulfillment, and it does all those fun things. That is a great time to use that because you got to bring down the web order and you got to interrogate it, especially if you're using integers as your auto-generated number, because you can't play a lot of games with that. If you're using GUIDs, it's a lot easier. It's going to be unique almost 100% of the time. But in that case, part of the order, you've got a very elaborate data model. You got the order, you got the customer information, you've got the detailed line items. You may have shipping information separately and so on. So that really expedites the process of changing those. Cascading deletes. Suitable for child records that have no independent meaning without the parent record. That's the only time I would utilize this. And that would be if I delete a customer, I want all the phone numbers to go away. I want all the addresses to go away. I want all of the whatever sub-elements we have. Now we got bigger issues of what if the customer has orders, but let's just say it's a contact management system where it stands alone pretty much. That's a perfect use of that. Cleans up your data. You don't have to worry about it. Again, appropriate for cleaning up temporaries or log files that are no longer needed. It does maintain referential integrity by cleaning the underlying, so integrity stays intact whenever you initiate the cascading delete. Avoid cascading updates. When using auto number fields as primary keys, you're not going to need it. You're not changing those values, so it's really not an issue if you've got it set up as an auto number. It could lead to unintended consequences. Imagine if we did the scenario where we changed the flag and we had 50,000 records looking associated with that particular flag in the entity table. You're going to bring the system down to a very slow pace and potentially cause contingency issues with locked records.
That's a good point.
Pardon?
That's a very good point.
Yeah, right. So yeah, I just wouldn't do it. Avoid cascading deletes for critical business data. You can accidentally delete it. I'm not a big fan of deleting in general. Most of my systems are ERP related or pretty critical. I don't generally let users just go out there and delete master level records. Complex relationships. Anytime you have historical or auditing data that needs to be preserved, that's ERP stuff left and right. You don't want to just go out and delete a customer, which then would trigger the delete of orders, which then would trigger the delete of potentially payments and everything else. Okay, best practices. Careful consideration. Always evaluate your situation. Determine whether enabling or cascading deletes makes sense. Data integrity. Use these options to maintain data integrity, but be cognizant of data integrity or data contingency issues, data integrity issues by deleting unwanted elements, and the performance impact. You got a reference table that's got 100,000 usages within one entity table, and you go and change that name, it's going to ripple through that table and cause all kinds of problems. User interface design, you just got to make it clear. I mean, it's like anything else. I don't believe we need to spend much time here. If they're deleting a record, they darn well better know what they're doing, know the consequences thereof, and I think your normal deleting process will tell you that. Alternative approaches, soft deletes, archiving strategies. I like these a lot better. Soft deletes meaning you create a status of delete and nothing looks at it from that point forward. Thoroughly test everything to make sure you're not going to bring down the system to its knees. So if you go out and set up these types of relationships and cascading processes, test the heck out of it. Okay, summarizing building relationships. Number one of all is data integrity. The relationship helps maintain data consistency and prevents orphan records. That cannot go without emphasizing enough. Efficiency in querying. If it adds speed, do it. It does improve query performance by stuff that Access does in the back end when it's rendering its query plan and the utilization of hidden indexes. Referential integrity, kind of falls under data integrity in my mind, but it ensures that all related data remains synchronized across the tables. We don't have orphans. We don't have, primarily we don't have orphans. Improves data entry with lookup and combo boxes. If you utilize the auto join, it will auto load it into your query elements. So if you're dealing with huge reports and huge queries, or lots of elements in a particular master-child level relationship, let it do the work for you. You can utilize the cascading updates and deletes. I think there is a time and place for it. Again, I do utilize it in temporary data storage when I'm trying to groom data to be loaded into master systems. And I really think that that's the best results of that. Or when utilizing it in a situation where you have a master table and dependent child tables that can't stand on their own. Just be cautious, maintenance overhead. It becomes ugly and ugly quick. This table, this is a very, very small system. Imagine if you had 100 tables in here and they're all related. I wish Access.
Now you have spaghetti.
You got spaghetti. You got it all over. You can't find where it's going. But that shouldn't deter you from doing the benefits, but what it will deter you from is using this as your documentation model, because it becomes more work than just building it out yourself and trying to get these organized and set up right, take snapshots and everything else. So if you're looking for a visual to this, there's probably better tools that'll actually give you an entity relation diagram. Complex relationships. I don't know why this guy came out. All of the relationships that you're probably going to come across are going to fall within the ability to put in the relational model. as discussed, performance issues on large databases, flexibility limitations, strict relationships may limit flexibility in certain scenarios. You can't have dissimilar field types if you're trying to join those together. So if you have legacy data and that structure is different than your current production data, can't create those relationships physically. You can logically create them and deal with them. This we use to not provide orphan records. So I'm going to pause on that one. The learning curve, that may be a little bit, but once you get a firm understanding and once you've done it a few times, you're doing the same thing over and over. 90% of your relationships are going to be one-to-many. So I don't think that should be a deterrent on building up your relationships. But that concludes the detail side of this thing. I do believe the benefits outweighs the drawbacks, and I don't believe I believe you should try to incorporate where they should be incorporated. And one, it helps maintain integrity. It helps building queries faster, reports faster, and it keeps the number one reason is the data integrity. As far as I'm concerned, if nothing else, that in and of itself is worth utilizing it where it best fits to be utilized. Bottom line, it's a powerful tool, utilize it. And what you learn from here can also be applied in any database, major relational database, whether it's SQL, Oracle, or just a
That's so true. That's so
Access
true. You work very well.
application.
Yeah, it is very true. It's, I mean, these principles you discuss, Postgre, MySQL, SQL Server, they're used everywhere. So once you dominate this, they're used everywhere.
Hey, Brian, and again, it's so repetitive. Most people are going to go into some of these really complex scenarios, like you had mentioned, some don't even use that many of many to many. I happen to use them quite a bit, but a lot don't. Probably even less people use a one-to-one relationship. Those are for very specific scenarios, and I don't think generally from a beginner standpoint you're going to come across that much.
Absolutely. Well,
I think-
Steve, really appreciate it. This was an amazing presentation. I know you covered a lot of ground. I encourage our viewers to pause the recording and look up these concepts and be able to research them and see what is beneficial to you. The best way of learning this is to start using these relationships in Access. Right now, we don't have anybody in the audience. George, do you have any questions before we go or any feedback?
No, I just want to say thank you, Steve. That was really good. I thought you covered all of the important stuff really well.
Thank you.
Wonderful. Well, look, if you're watching this on YouTube, why are you doing that? Because you could have been here asking Steve questions about relational integrity and relationship advice. Steve has a ton of experience testing Access from the first version. You missed out on a great opportunity, so please join us in February, third Tuesday of February. We'll have another great chat. You can see our calendar at AccessUserGroups.org/calendar, where you can also sign up and get our newsletter and reminders about future meetings. I'd like to thank Steve, our guest presenter for today. Steve, amazing job as always. Thank you very much. Looking forward to have you back later on this year, I'm hoping.
Absolutely.
Great. And I've got George, who is the president of Access User Groups Pacific. George, thank you again for being with us tonight.
My pleasure. Like I say, I really enjoyed it.
Why don't you give us a little hint as to what you got coming up in January and February for your group?
Well, if I had thought ahead, I would have had my slide up. In February, we're going to have Adam Waller, who has a source control application for Access. Now, we know that Microsoft has announced that they're going to bring source control back
Yes.
at some point, and I'm doing the air quotes at some point. But in the meantime, Adam has a tool that he offers. I think he has a GitHub site, and that's on my slide. I can't give it to you, but he's
That
going to
promises
talk
to be a
about.
really good presentation. I'm
Yeah,
gonna
his
try and make it that one.
Yeah.
Thank you,
And-
George, for that, and Chancellor, thank you for always being here at these meetings.
Oh.
Again, this has been Juan Soto. I'm Access MVP and the president of Access Beginners. And we appreciate you watching us on YouTube. And until next time, thank you, everybody. So long.
Right.